Okay, the topic of this video is solving quadratic equations using square roots. Okay, we're going to talk about four processes: solving by square roots, solving by factoring, solving by completing the square, and solving by the quadratic formula. There are four different methods. You need to for sure learn one of them. Okay, as I tell all my classes every single time I talk about this topic, if we are looking at solving something on a standardized test, for instance, you're not going to have a proctor, the person monitoring the room, come behind you and say, oh, hey, you're not answering this by the property that we're asking for, because typically they don't even know. Okay, you're going to choose one of them to learn to solve. I prefer that you know all of them, but you're going to use at least one of them. And for most of you, that will be the quadratic formula. Okay, so for some of you that struggle, my suggestion might be that we just skip through and go straight to solving by the quadratic formula and work out every problem from here through the rest of the unit in that manner. Okay, but we're going to still go through each of these processes. Okay, so again, this one is only solving by square roots. On bell work, this should look familiar. This is just simplifying square roots. This is going back to a previous section, the first section of the unit, in fact, and we're going to find the perfect square factors underneath these square roots, and we're going to work them down so that we have a number times a square root that does not have a perfect square factor. Okay, I'm going to take 375. And I'm going to factor it out. I have 1 times 375. 2 does not work, but 3 times 125. 4 does not work, but 5 times 75. 6 does not work. 7 all the way through 14 do not work, but 15 times 25 does work. Again, then we're going to go through the list and identify the largest perfect square factor. Okay, 375 is not a perfect square. 125 is a perfect cube, but not a perfect square. 75 does not work, but 25 is. Okay, you'll notice that I always start on the top right side and work my way down. If we do not find a perfect square on this side, then you still have to proceed to the left side and work your way up. Okay, we're looking for the largest perfect square. Again, then I can rewrite this as the product of those two. And again, my suggestion is to put the square root, or the perfect square, in the front. So this is the square root of 25 times 15. Using my multiplication property here, then I can split this up into two different ones. So square root of 25 times the square root of 15. Square root of 25 is 5. So this becomes 5 square root of 15. Second one there, square root of 28. Again, I'm going to take 28. I'm going to factor it out. I have 1 times 28. 2 times 14. 3 does not work. 4 times 7. Okay, and that's my entire list now. I'm going to find the largest perfect square factor. 28 is not. 14 is not. 7 is not. So again, as I stated on the other side, I'm going to go to that left side and work my way up. Okay, 4 is a perfect square, so I can stop there. Okay. Again, taking this now and breaking it apart, this becomes a square root. Stay consistent with our colors. Square root 4 times 7, again putting 4 in front because it's a perfect square. Separate it using the property, so this becomes the square root of 4 times square root of 7, which then becomes 2 square root of 7. Next one here, square root of 1100. You will see sometimes some rather large numbers. Yes, you are going to have to factor them out. Okay, you are going to have to go past first 10. All right, some of them will have a list of 15 or 20 sets of factors. You need to find all of them to be sure that you're not going to end up with the wrong number. Okay, some of them could be, in fact, again, perfect squares. So if I take 1100 and I take the square root of that, I will see that that is not a perfect square. Okay, but 1100. 1 times 1100. 2 times 550. 3 does not work. 4 times 275. 5 times 220. 6 does not work. 7, 8, 9 do not work. 10 and 110. 11 and 100. 12 through 19 will not work, but 20 and 55. 21 does not work. However, 22 and 50 do. 23 and 24 also do not work, but 25 and 44 do. And we'll see that 26 through 43 do not actually give another set of factors. Okay, so this is my entire U. Again, I'm going to go through. I'm start at that top right portion of the list there. 1100 is not a perfect square. 550 is not a perfect square. 275, 220, and 110 are not perfect squares, but 100 is. So this is the largest perfect square set. Again, then I'm going to take this and separate it. 100 times 11. Using my property, that becomes the square root of 100 times the square root of 11, which then becomes 10 square root 11. Okay, solving quadratic equations. You are going to be given an expression that will contain a squared variable. That will be the highest power that you see, okay, in these problems. We are looking for the zeros or the roots of the function. Again, these are also the x-intercepts, but are presented differently. As stated previously in the beginning of this video, I mentioned that there are going to be 4 processes that we are going to work with. The first of which is what this video is on, using square roots. The next video will be on solving by factoring. The third video will be solving by completing the square. And the fourth and final video for this unit will be the solving using the quadratic formula. Square root facts. Did you know that there is actually technically two answers when you take the square root of a number? Okay, the first one is what you are typical and familiar with. That is called the principal root. That is the root that you are used to, and it's the positive one. Okay, so if I take the square root of 4, I'm just going to have 2. But when I take this and attach it then to an equation, I need to account for the fact that -2 times -2 is also 4. So that gives me the negative root. So if you have a square root of a number, you have a positive and a negative. We're going to indicate that with a sign that says plus minus. It's going to be a positive sign over a negative sign. Okay. Okay, procedure, and then we have 5 different examples to work through. Solving by square roots. Number 1, you're going to isolate the term that is squared. Isolating means that you're going to get it by itself. Okay? You want to only have that squared item alone. You don't want a set of parentheses. You don't want any of that. You want to just get it by itself. Okay, so it could be a term. It could be just the number or the letter, or it could be an expression. So it could be a set of parentheses on the outside. It's squared. Okay. Step 2, you're going to take the square root of both sides then. And then this is the part we're going to have to remember. And this is the part that I see consistently incorrect. Because you have to have the positive or the principal and the negative roots, okay, accounted for. Step 3 there, if there is a square root in the denominator, you're going to have to rationalize and multiply in the top and the bottom by that square root in the denominator so that we can eliminate that denominator. Okay. And again, I have an example with that on here, so bear with me. Step 4, then you're going to solve for x. You're going to solve an equation. Okay, this could be including adding and subtracting a number that is added or subtracted or added to the x term, or you could be multiplying or dividing a number that's multiplied or divided onto that x term, okay, or whatever the variable may be. Step 5, then you're going to simplify if possible. Okay, so first 2 problems here. You'll notice on the left side here of number 1 that the x squared term is already isolated. It's by itself, okay? But I still want to get x squared alone because I have a number 12 that's attached to it for the coefficient. So to do that, I can divide both sides by this number, so by 12. That's going to cancel the 12s here. That leaves me x squared equals, and if you take 1,728 divided by 12, you end up with 144. Okay. At times, you start the problem right here at this step. So if you start here, then you go straight to the next step that I'm about to do. But if you have a coefficient on that x squared, you need to divide like we just did. Okay. From here, then you take the square root of both sides. Again, what you do to the left side of an equation, you have to do to the right side. Here, the square root and the square cancel. So that's the idea here. This becomes then x equals, and again I stated once we take the square root at this step, don't forget the plus minus symbol. That is where a lot of people are going to mess up. You need to make sure that you have both of them. Okay, square root of 144 is 12. Right? So I would take this as an answer because x equals positive or negative 12. Some of you may want to see that separated, so you could write it as x equals 12 and x equals negative 12. Okay, some of you are going to, again, be particular about that and want to see it separated. That's up to you. Again, be your own advocate here. Okay. You could also then take these and plug them back in and check your work. So just go back and plug it in for the x. So if I took 12 times 12 squared, I would get 1,728, which would tell me that I'm correct. I could also take 12 times negative 12 squared. I would also get 1,728, which again would show me that I'm correct. Okay. Number two, then I've added something to this. So now I don't only have a coefficient in front of the x squared term, I also have a number that is added or subtracted to that term. So here I need to get rid of that 5 first. I need to get rid of the things that are furthest away from, but on the same side as the x squared term. So here, I'm going to subtract 5 on both sides. Then things come down. I have 7x squared left. These cancel. Equals. Okay, come straight down. 15 minus 5 is 10. I'm going to then divide both sides by the coefficient. Again, if I have it, I have a 7 here. That leaves me x squared equals 10 over 7. Okay. Notice that 10 over 7 does not nicely divide, and it does not reduce. Do not put this as a decimal. Make sure you leave it as a simplified fraction. Okay. When you take the square root now, the difference between what we did before and what we have now is again that fraction aspect. So when I take the square root of both sides, when I have a fraction, I want to take the square root of the numerator and the square root of the denominator separately. So square root of x squared, and I'm going to do square root of 10 and the square root of the 7. Okay, that's going to leave me x equals, again, plus or minus. Once I take that square root, kicks into play. Okay, square root of 10 is not a perfect square. Square root of 7 is not a perfect square. Okay, so the problem here is that I have a square root then in the denominator that needs to be rationalized. And I do that again by multiplying the top and the bottom by that square root. So I'm going to multiply here and here by the square root of 7 because that's what's there. Okay, and then I'm going to undo that property that we've talked about in the past. I'm going to take and I'm going to put these together. So this becomes the square root of 10 times 7. And this becomes the square root of 7 times 7. Which then, if I continue, plus or minus, 10 times 7 is 70. 7 times 7 is 49, so I have the square root of 49. And the square root of 49 is 7. So I have x equals plus or minus square root of 70 over 7. Okay, again, some of you will be able to skip some steps here and not write out all that work. Okay, however, some of you, again, will need to physically see that work written out so that you can comprehend every time that you do it. Okay, again, I cannot stress enough, especially in sections like this, be your own advocate. If you don't understand this content for quizzes or tests, that could mean major trouble with this section. Okay, so make sure you work it out as best as you need to. Okay, 3 more examples here. Number 3. Again, similar situation to what we had before. I have 2 things now done to that x squared or that squared term. I have 2 times it. and then I have the 9 added to it. So I'm going to subtract the 9 first. Maybe. There we go. That's going to give me 2x squared equals, we have 96. I still have the x squared with a 2 on it, so I need to divide now both sides by 2. Which leaves me x squared equals 48. And at this point, I take the square root of both sides. So I have x equals, again now, plus or minus square root of 48. In the first example we did when we got to this point, we had a perfect square. 144 was a perfect square. However, 48 here is not a perfect square. So we still need to check and see if I can simplify. I do not want square roots. Again, I want a simplified, I do not want a decimal. I want to see a simplified square root. Okay? So 48, I need to find the factors. 1 times 48. 2 times 24. 3 times 16. 4 times 12. And 6 times 8. And again, looking from the right side, going down, and then coming back to the left side if we need to, and going up. 48 is not a perfect square. 24 is not a perfect square. However, 16 is a perfect square. So I'm going to use this set to break this up. That means this then becomes x equals plus or minus square root of 16 times 3. And again, using my property, I'm going to undo this square root to be square root of 16 times the square root of 3. And the square root of 16 is 4. So plus or minus 4 square root of 3. Okay, number 4 is slightly different. You'll notice here now that I don't have a squared term. I have a squared expression. Okay, you do not want to undo that expression. Leave that expression alone. Okay. However, the number that's on the outside there, if one exists and is multiplied to it, then I can get rid of that first. Okay, so here I have this 3. I'm going to divide both sides by that 3. When I do that, this expression is going to still come down. Okay. Again, I'm going to leave that intact. I don't want to mess with that. If I take 432 and I divide that by 3, I get 144. Okay. And again, I'm at that point where I have only the squared item by itself. I'm going to take the square root of both sides. And again, what happens here is the square root and the square will cancel. You can then at this point remove the items from the set of parentheses. So this would be x minus 4 only equals, again we have plus or minus, don't forget that. And the square root of 144 again is a nice number, and it's 12. Okay, we then have to continue because now I have something that's still attached to that x. So I'm going to move that 4, and I'm going to do that right here in front of that plus or minus. So that gives me x equals 4, because I'm adding it, plus or minus 12. At this point, if we have a square root still there, then we're done. However, here we don't have a square root, so I can continue with my process. I'm going to take this then, I'm going to separate it into 2 problems. This becomes x equals 4 plus the 12. And this one is the opposite one, x equals 4 minus the 12. Okay, you have both cases. 4 plus 12 is 16. So that's one of my answers. And 4 minus 12 is negative 8. And that's my second answer. Okay. Again, with these, especially if you come out with nice numbers like this, my suggestion would be to plug in to make sure that you get the correct answer back. Okay, so don't move anything around. Go back to the original problem here. Take x, or 16 here. 16 minus 4 is 12. 12 squared is 144. Multiply that by that 3, you do get that 432. Okay. You can also then take the negative 8. Negative 8 minus 4 is negative 12. Take that squared to get again that 144. Multiply it by 3, we get the 432. So both answers checked. Okay. And if they check correctly, then that means you're correct. Another example here, for this one, notice that I have, again, multiple things going on. I have a expression that's squared, not a term. I have that expression then multiplied by a number on the outside like I did for the last problem. But I'm also then adding a number to it. Okay, so how you approach this is up to you. Here, since we have 2 in front, a 6 that's added, and a negative 36, all of them can be divided by 2 first if you want, or you can subtract the 6 on both sides first if you want. Again, 100% up to you. Sometimes they don't divide so nicely, so you're going to have to then subtract or add fractions, and several people struggle with that, and that's just reality. Okay, so my suggestion would be typically to get rid of whatever's added or subtracted here first. So we're going to do that. Minus 6 minus 6. That whole thing comes down to a 2 times x plus 8 quantity squared equals, this is negative 42. I'm going to then divide both sides by the 2 that's outside here. That gives me x plus 8 quantity squared equals negative 21. I'm then again at that point where the x squared expression is now by itself, so I can take the square root of both sides. Square root and square cancel. Again, I can then remove this from parentheses, so I have x plus 8 equals plus or minus square root of negative 21. Okay. Then again, now I need to move this, so I need to subtract 8. And again, I want to put it right here in front of the plus or minus. So x equals plus or minus, sorry, x equals negative 8 plus or minus the square root of negative 21. Okay, we need to then simplify here. So the negative 21 under the square root doesn't in fact have any perfect square factors, but let's list them out just to check. So the factors are 21, 1 and 21, 3 and 7. None of which are perfect squares except for the 1, and that doesn't help us at all. Okay. However, we do have that negative underneath there. You need to pull that negative out. And if you remember from the operation with complex numbers section, that means that that's going to become an I. Okay, but just to show it, let's work it out. X equals negative 8 plus or minus square root. I have negative 1 times that 21. I'm just going to work it out this way because we're going to run out of room on the board here, on the bottom here. So then I have a negative 8 plus or minus square root of negative 1 times the square root of 21. And the square root of -1 is again then I. So -8 plus or minus I square root of 21. Okay, then that would be our final answer. Okay, I do think, sitting here thinking about some of the worksheets that I do provide on this section, I do want to touch base on another example. So I'm going to clear this out, and I'm going to use this page. Okay, and we'll do a number 6. Okay, and I'll do a basic version of this. Again, this applies to anything that's a little bit more extensive. But if I do something like, let's say, 2 times a squared minus 5 equals, I don't know, let's go with 8. Okay, notice that the squared term is not outside the parentheses, but inside. Okay, so I still need to get that squared term by itself. So my suggestion, since we have this setup, is I'm going to divide both sides by 2. Again, whatever's outside here. That would then leave me the a squared minus 5 in parentheses equals 4. Okay, but with this, do we need the parentheses still? All right, again, that squared is not on the outside. The squared is in the inside of the parentheses. So I could have actually dropped those off and left me with just a squared minus 5 equals 4. I can then add 5 to both sides, which leaves me a squared equals 9. And again, now I'm at that point where I can take the square root of both sides because I have now the x squared or the I squared or whatever squared term here alone. Squared and square roots cancel. I have a equals, again, plus or minus. Square root of 9 is a nice number. It is 3. So that is now my answer. Again, I can go back and I can plug that in to just check and verify that those are correct. Okay. As always, if there are any questions, comments, or concerns, or if I can help you out at all, please, by all means, feel free to reach out.